Hello, this is the brief overview for the week 3 material, which is chapter 6, 7, 8, 9. So it's mainly for the chemical reactions. So we are mixing some chemicals and how to express in a chemistry way. So let's take a look at the slide that for the chapter 6 first. Okay, so Chapter 6 is the chemical reaction. And when you take a look at it, the main key thing is for the chapter 6 is how you write the chemical equation. The reaction that we do, we have a mathematical way to express them. So when you see these equation first on the below, you can see the two chemicals on the left side of the arrow and the right side of the arrow. So that the arrow pointing towards the right side from the left. So the left side two chemical is the reactant, and the right side of two chemical is the product. So the methane and oxygen is reactant, carbon dioxide, and the water is the product. And then based on the law of conservation of mass, you will have to have a same number of atom in the reactant side and the product side. So when you're see the unbalanced equation, total number of carbon is 1 and 4 hydrogen and then 2 oxygen in the reactant side. And then product side, you have 1 carbon and then 2 hydrogen and 1, 2, 3 oxygen. So it's not balanced. So you have to adding 1 oxygen on the reactant side and then 1 water in the product side. And then you counting all the number of the atom is 1 carbon, 4 hydrogen, and 4 oxygen for the reactant side, as well as the product side. So between product and reactant side, all the number of atoms are matched. So that's the main thing that you need to do. Also, when you're writing the chemical equation, you can express the physical state. So parenthesis, S is a solid, L is liquid, G is gas. AQ means in aqueous solution, so the dissolved in the water. Typically, we use it for the salt because, for instance, sodium chloride, when you put it into the water, they will be separated as a cation, which is the positively charged ion, and then anion. So sodium as a cation, sodium plus, and then the chlorine minus, aqueous solutions. So when you're writing the equation, you can take a look at it. So that potassium is a solid, and then you mix with the water, which is the liquid. Then hydrogen gas will be evolved, and you will make the potassium and hydroxide ion is an aqueous solution. So you write all of these equation, and then all the number of atom on the reactant side, all the number of atoms in the product side should be matched. For this one, it's not matched yet, but when you're writing it, you should match those things together. But anyway, it's the example to show how to write the physical state of the in the chemical reaction. So you can take a look at the balance equation so that first you have to identify which one's going to be the reactant and which one's going to be the product. That'll you can identify based on the questions. They will say something like, I mix this compound A and compound B, and I produce so and so compound C. Then the one that you mix it to produce this compound C, which is the chemical A and B, it's going to be the reactant, and the compound C is going to be the product. So the first, once you identify it, you can write the unbalanced equation. So then you have unbalanced equation. There is an example right here, which is the hydrogen gas and oxygen gas mix. Then you can produce the water. But if you're counting all the atom between the reactant and product, numbers not match yet. So it's unbalanced, but at least you write the chemical equation so that identify the product and reactant. So then now you matching them, and then you will have to adjusting the number of all the uh, atoms between product and reactant. So you can adding more water on the other side first so that you can matching the oxygen number, but then you ended up adding 2 more hydrogen. Then the right side, you can adding the hydrogen atom more. So then total 4 hydrogen and 2 oxygen in the reactant side, and then 4 hydrogen and 2 oxygen in the product side. So number of the all the atoms are matching between reactant and product. Then how you writing it? It's going to be the, you are using coefficient, meaning the number 2 in front of that molecule. That means you have a 2 hydrogen molecule, and then 1 oxygen molecule will produce 2 water molecule. This is, you can express as the 4 hydrogen, 2 oxygen can make 4 water molecule. However, you want to factor them out, and then smallest integer ratio between all the species of the molecule. So these will be better expression. So that's the pretty much main thing for the chapter 6. So let's go for the next chapter, which is chapter 7. So chapter 7 is about the chemical reaction in the aqueous solution. So basically, reaction can be occur in any environment. It's in the air or the solid mixture. But for chapter 7, the environment of the reaction is going to be the water. So to see the chemical reaction in aqueous solution, you will have to know the solubility of each of the chemical compound, so that we will predict the chemical reaction based on the solubility of the salt. So that's going to be the chapter 7, so that you will have to see the important tables later. So that there's the driving force for the chemical changes, which is the formation of solid or the water, or based on the chemical reaction, electron can transfer from one atom to the other, or chemical reaction will evolve the gas, so that you will know the type of reaction based on these chemical change. So the solid formation in the aqueous solution that we call the precipitation. So that this example is the one of the precipitation reaction. So there is a Cr2, K2CrO4 dissolved in the water, which is the aqueous solution. Then you will have the potassium cation, and the chromate anion. On the other beaker, you have a barium nitrate. So when you put it into the water, you will have a barium cation and nitrate anion. So if you mix these together in the one container, then you have an option of potassium cation can interacting with either nitrate or the chromate. If it's the barium, then it also has the nitrate or the chromate anion, because cation wants to interacting with the anion. So there is a 2 cation and there is a 2 anion. They can interacting if they are all in the same solution. So then whichever has the stronger attraction, they want to be together and they don't want to interacting with the water. So then they will make the solid form. So the rules for there's a rules for the solubility, so that these are the general rules. So that whatever the salt has the nitrate, that's going to be a soluble. So barium nitrate is going to be aqueous solution as we see it. And most of the sodium, potassium, or ammonium ion with some other anion, that's going to be soluble. Most chlorides are soluble, but there is an exception of these. Not soluble means when you put these into the water, they're going to be stay as a solid. And same thing for the rule 4. Most of the salts, sulfate salts are soluble, but except these things. And so on, there is a rules. And then, you know, when you have the chemical reaction, for this chapter, they will give you 2 different salt and then expecting what will happen. So then whether they will have the, you know, precipitation, which is the solid formation, or nothing will happen based on these rules. So let's see the example. So which of the following ion reacts with the lead ion to form compound are generally soluble in water? So the lead is the cation. So cation, we should just rule it out because, you know, they're not interacting because they're both cation. And then the chloride ion, it's usually soluble, but there's an exception of them. So let's take a look at the solubility rules. See? So chloride ion is not soluble with the lead chloride. So the chlorine is not working. And then sulfide ion, if you go back to the solubility table, then these are generally insoluble with pretty much any salt. There might be a very few exception, but that's not included with the lead. So it's not soluble. Sulfate also, you can take a look at them. So then lead sulfide is insoluble because it's exception of the soluble. So then you have a nitrate. Nitrite, so by the way, this is typo. It should be NO and 3 subscript and -1. So that -1 charge is not -3 minus charge. But anyway, these are mostly soluble with any cation. So the answer is C. So in the exam, these solubility rule table will be provided. But when you have these kind of questions there, you should be able to find out, is it going to be soluble with what kind of a counter anion or cation? If there is some kind of exception, or is it just the general rules, you will have to identify them. So it's not about the memorization. It should be the interpretation of what you need to do. Okay, I think I will make the separate video for chapter 8 and 9. So see you at the next video. Thanks.